Okay, folks, we're going to be working on a second set of Chapter 15 exercises tonight. We're going to start with exercise 15.9. And this first one says, draw lines using the arrow keys. Write a program that draws line segment using the arrow keys. The line starts from the center of the pane and draws towards the east, north, west, or south when the right, up, left, or down arrow key is pressed. And so if you look at your keyboard, folks, the arrow keys, depending on the kind of keyboard you have, usually will be in between the number pad and the regular keypad if you have a full-size keyboard, or they're going to be right below your shift key, typically on the right-hand side of the alphanumeric part of your keyboard. And so that's the arrow keys that they're referring to, by the way. Before we dive into this exercise, I know that this seems like a silly little kind of like etch-a-sketch kind of exercise, but at the same time it is teaching you very rudimentary game mechanics, by the way, so anybody that's interested in game programming. And what I often have students do is, people who are gaming often don't think about moving up, down, left, right using the arrow keys. They usually think about WASD. And if you guys don't know what I'm talking about, you're probably not a gamer. But if you are a gamer, those are really critical movement keys in most games. So you're welcome to.
It'd be weirder to use the arrow keys.
Yeah, I think it is weirder to use the arrow keys. So whenever I do this one lately, I always tell people, hey, if you want to do WASD, that's totally cool. I understand and go for it. All right, so this is actually once again seemingly a simplistic little exercise, but very powerful in its capabilities. So I'm going to go over to Eclipse, and since we are working on a new set of exercises, I'm going to begin by creating a new project just to keep them separated. And this is, my preference. So I'm just going to call this project Chapter 15, Part 2, just following the naming convention I used last time. And then I'm going to go ahead and click Finish. I'm trying to get all my other tools up on the screen here, of which there are many, as you can see. Just trying to get the right screens going. Yeah, you can see my grading comments. So you guys want to see this grading comment? Because some of you may have received this. I don't think any of you did, but if you do get a 0 in your grade book, it's because the due date has passed on something, and it doesn't mean that you can't still turn it in. So this is a very typical comment I put in, but I also let people know if you're turning it in at this point, you're probably going to see a reduction in points, by the way. So now that the project has been created, let's go ahead and create the first class file inside here. And in fact, I'm going to make sure that I'm on top of the source folder when I do this. So I'm going to say new class file. This is going to be exercise 15_9. And I'm going to go ahead and add the main method as we normally do. I'm probably going to borrow a little bit of code from some of the other apps, the stage and the scene and all that, as I normally say. So if you guys are feeling ambitious, please go right ahead. On my other screen, I'm opening up my cheat sheets, if you're wondering what I'm doing, not being active on this screen. So I'm just being real, full disclosure here on it. And I'm just trying to find my solutions, basically. All right. So I have my cheat sheets up on the other screen just so I can remember how I did it last time. Right? If you guys think I'm a brilliant coder, sometimes I am, but sometimes I just plain forget, and I still need to look at a reference just to make sure even I'm working on the right exercise sometimes. All right, let's go ahead and do the basics here. Let's get rid of some of this unnecessary stuff. Let's put in the launch directive immediately in the main method. All right. The other thing that I'm going to do is I'm going to come up here and I'm going to extend application class, control space to get the library for JavaFX added. And then we will hover over the class name and add the unimplemented method, which is the start method. Moving the main method down to the bottom here, that's just my typical pattern. You do whatever you want. Frankly, some people like to leave it at the top. A lot of textbooks leave it at the top, by the way. That's not how I like to operate. Since this is the only command in here, I'm like, what's the point? Just put it at the bottom. Let all the other code read it in first, then launch the program. All right, I'm also going to backtrack a little bit here, and I'm going to go back to my Chapter 15, Part 1, and just open up one of the last applications just to copy this stuff in, which is the stage and the scene. And let's get that at the bottom of the start method. And then let's make sure that primary stage thing is matching up names, and it looks like it is. All right, now that we have those mechanical things out of the way, now we need to start thinking about the kind of visual structure that we're going to build this application into. And this is a pretty common, first step. And that's one of the big differences, I think, between GUI programming and what I would call console programming is, GUI programming shares with web development the aspect of like you're thinking about like what you're creating on the screen first. Now, we're not going into the process of like wireframing this or anything. This would be a boring one to wireframe, by the way. But we do want to think about what kind of interface we're contending with. And it would make sense that if you're drawing lines on the screen, it would be nice, we're not being asked to create buttons, right? We're going to use the keyboard to do the drawing. But we are seemingly should be allowed to use the whole screen, is kind of my thinking. So the structure that would lend itself well to that is just a plain pane class. So one big pane that fills the whole screen. That makes the most sense. So that's what we're going to create. So I'm going to come back to the start method here, and I'm going to create a pane class, control space for the library. And I'm just going to call it pane. And the main reason I'm calling it pane is it's already down here. So why not go with the name that's already there? So I don't have, that's one less piece of code to copy. And then we're just going to go ahead and instantiate a new instance that's empty. Now, in terms of size, last time where I copied this from, we went with 400 by 100. You know what? If I'm going to be like moving stuff around the screen like an Etch-a-Sketch, I want more space than that. I'm going to go 500 by 500 because I'm going to draw some Etch-a-Sketch magic when I'm done, hopefully. It's that diagonal line that always gets you, though. All right. This is exercise 15.9, and I think it's called Draw Lines. Okay, so we have that piece done. Now, the next part of what we have to do is actually almost kind of strangely simple. And this is what's so beautiful about this, because we are going to draw a line every time we press a key. Now, every time we press the key, we really can't tell from this drawing, but how long of a line will we make every time we press the key? Are we going to go 1 pixel at a time? That's probably going to take a while, right, to get across the screen. I'm going to propose that we just pick a number at random to do this. And my thinking is, why not start with 10 pixels per key press? That might be a reasonable amount. The other thing that I'm going to do is I'm noticing that they want us to start from the center pane, the center of the pane, and then pick whatever direction you want to go. So if I'm working with a space that's 500 by 500, I'm going to set some global variables here just to hold starting XY positions, by the way, for the first point of origin, basically. And so I'm just going to create 2 private variables here. Both of them will be doubles. And we're going to choose 250 for X. And why am I choosing 250? Because that's halfway across 500, basically. So I'm predetermining my X and my Y. I'm hard coding it. So now if I decide later to change the size of the window, I could, I could write these as variables too, honestly. I could, mathematically adjust this. And in fact, one way I could kind of dynamically adjust this is I could just say, X times 2, right? Or, for example, Y times 2. And so if I come up here and, I change my X and my Y, the size of the pane or the window will change also. So if I change this to 500, the windows will be 1,000 by 1,000. If I change it to 50, it'll be 100 by 100. See the trick there? So dynamically changing window size. The other thing that's, kind of a thing that you had to read about in the chapter, by the way, to figure out is when you're going to be creating stuff on the screen, so like drawing a new line segment or putting an object on the screen dynamically with the keyboard, you have to tell the pane that it is going to be focused on and traversed. And I want to talk about the meaning of these words here before we proceed. So when you're working with an application, focus is what is given attention on the screen. So I want you to think about that really carefully. So when you go to a website, so if I go to let's say I bring Facebook up on the screen. Where's my focus drawn here? Where's the focus set on this screen? You guys notice how the cursor is flashing in the username box? That's called focus. And the reason I can type in that box is because some intelligent programmer decided that the moment you land on this web page, put the focus inside that text box so a person can just start typing. Otherwise, if focus was not set, I would have to move my mouse all the way across the screen and click into the box, and then I could type in it, right? So that approach is called setting the focus. Now, that's what we're doing in our application as well. We're saying that the pane is, we're going to set the focus on the pane, and we're allowing the pane to be traversable with GUI objects. And so we're setting that feature to true. If we did not do this, our key presses would do nothing because they wouldn't know where to draw to. That's what we're doing. And so what we're saying here is, this is the equivalent of like click, and now we can draw. That's what we're basically doing. So we create the pane, and then we're basically via code clicking into the pane so it's active, so that the keys become active. Now the next part of this is kind of fun because we're going to be able to, with very simple Lambda codes, draw inside the pane. And we're going to go with, once again, with the default action for a key on the keyboard, which is on key press. And I want you to notice the different options that come up with on key when I just type that. So one is when you press the key, you can have a different action for releasing the key. And then you can have a different reaction for if the key has been typed in the aftermath. All right. So these are kind of like weird little event handlers, but these are the default ones for key. The default one is the one that we see here, on key pressed. So the moment you press the key. Now, when we press the key, we will bring up our Lambda event handler with a little pointer, and then we always do our curly brackets, and then the curly brackets are terminated inside of here with a paren and then a semicolon. So all the code we're going to execute is here. I usually type this first and then split it because that helps me keep my syntax straight. What happens sometimes if you start the first curly bracket and then you just start typing all this other stuff and you forget about the second one, or you forget about these two pieces. But this is the right way for this statement to end, is with all three of these, by the way. All right. So now what we're looking for in this case, and they wanted us to use the up arrow and the left and the right, and we've decided, we're gamers, we're doing it a different way, right? So the key code that we're going to look for is a capital W to go up. I'm going to go up first. That's going to be my first code. So the way we're going to write this is, I want to make sure that when the key is pressed, that we are checking if a certain key is pressed. So there's your first clue, right? So we're going to start with an if statement that just basically said, with the event handler, we're going to get the code of the key that was pressed. So all that command does is it grabs the keyboard event, whatever key is pressed, and then we are going to check it. So we're going to check it against if the key code is the letter W. And I am putting in a capital W, by the way, if you're wondering. Now, that ends that set of parens. That's what we're testing for true or false. Now we're going to put in a set of curly brackets here, And if a person did happen to do that, we need to draw a line. So that's going to be actually a pretty easy thing to do because we've already created those. But I am not missing the fact that this is underlined. So I am going to control space here at the end and make sure that we get our input library added. Back down inside the true part of the if statement, I am now going to tell the pane to get children like we normally do. And then we're going to add one single object, which will be a new line. So we're instantiating on the fly. The line's not created until we press the key, right? And then line is going to have some parameters. Okay, so this is kind of interesting. Well, first of all, we're going to need a library. So let's do that part. Import line Javafx scene shape. All right, and then if I hover, it should bring up the Java docs for me here. So I'm going to go into the description. I'm going to pull it up on screen, and I'm going to look at how many parameters should I throw in. Is it just enough to get the starting XY and the ending XY if I'm making a line? Well, the answer is yes. This looks like the right one to use. So start XY, end XY. That's all you need for a line. And so I'm going to come back here, and I know I have to put in some values. Now, the starting point's easy, right? Because we already started at 250X and 250Y. So with the first key press, X can just be X, and Y can just be Y. Now, after we press the key, so this is when we press the W key, we are assuming we are going up on the screen. So which one of the two dimensions are we changing, X or Y?
Y.
Y is correct. And if we're going up the screen, Y is going which direction, positive or negative? Negative is the answer because 0 is at the top of the screen. Remember, 0, 0 on the screen is up here. So X gets bigger this way, Y gets bigger this way. So if we're going up, Y is getting smaller, not bigger. So X won't change because we're going up, but Y will change. And what we determined is we're going to move up 10 pixels. So I'm just subtracting 10. And that's enough to move it. Now, the only thing that you might forget when you're doing something like this is now that the line has moved, the Y variable has changed, right? So the starting point for Y has changed because the next key press, we want to go up from where we went up from. And so Y will then get a minus equals 10. So we're just recording how far we moved it. Okay. Now, some people will say, well, Ty, why don't you just do this before this statement and then just put Y here? I'm like, well, then it messes up the starting position. See, that's why you have to do it after, right? So if you're thinking you're being clever by wanting to put it before, that's why it's not clever, by the way. All right, so that's if we press W. We can actually just kind of move forward now and code in all the keys. But you know what's more fun is to actually go ahead and get this on the screen and see if up works. And right now I don't see any underlines or highlights or anything like that. So I'm saving my work and I'm going to hit the play button and let's see if we can get up working on the screen. So we don't see, by the way, the starting point, but somewhere in the middle there is, you know, this screen has been waiting for us. All right, so I'm going to hit the W key. Nothing happens. Why? Somebody will get it. Capital W. So now I hit my, wait, I got to click on the window here too. Capital W. Nothing. I fail epically. Okay, so we got a problem here. So now I got to go back and check, basically, what did we do wrong? And so I got set on key pressed. I'm looking at my Lambda event handler. If we press the W key, we will add a line segment that moves up. Are we missing any piece of logic here? And this was in your readings, by the way, and I'm just going to point this out. So this is kind of my test. Did somebody do the reading? All right, so I'm going to type the answer here. what we also have to do with that focus command is request focus. And here's the problem. You can set this to be traversable. This is the one that actually does the click or makes it active. And unfortunately, I can't do this until it's been added to the screen. So first we have to put the pane on the screen, then we can click on it. Okay, so now watch the difference. Saving it, clicking the play button, and now watch the screen. And by the way, it's not a capital W. Lowercase w works too. And none of my other keys work, but that one does. Okay, so, and it works gloriously. I can draw a straight line going up. I'm so proud. All right. Now with the rest of this stuff, it's really going to be a matter of kind of repeating the if statement. And so I see some people will write this as a series of ifs. And by the way, that works. But it's really kind of functionally equivalent to doing an else if. And all you really have to do is change the letter. So to me, if I'm going up, the next logical one is down, which is the S key. And in that case, which are we changing, the X or the Y? Yes, Y is correct.
The Y.
In which direction are we going this time?
Yeah, to
Down.
be positive, like
Excellent.
plus 10.
Correct. And then make sure that you change this statement to match, so it keeps track of where Y is now. All right, so that's the next one. Now we can follow this pattern for the next two. So I'm just going to copy these, paste them twice, and then I'm just going to change the key. So left will be A, right will be D, and then if we're going left, we're not changing the Y, we're changing the X, and we're making the X smaller or bigger?
Smaller.
Smaller to the left, right? And then make sure we change this to match. So this has to be X minus equals. And then down here, we know it's going to be X again and will be plus equals. And this time we will say X plus 10 and remove this little bit from here. All right, so this is fascinating because this is all the code. This is the whole program. You know, there's not a lot of code going on here, but I want to show you how simple it is and how powerful it is all at the same time. So with a very little bit of code, we are now going to be drawing lines in every which direction on the screen. So I'm going to go ahead and hit play here, save my work, and let's get busy. So there's W, A, S, D, W. That's pretty good. Now here's WD alternating. Here's WA alternating. Here's AS alternating. Here's SD alternating. Here's A. And so it's like totally like a bad Etch-a-Sketch. And if you hold the key down, right, it just keeps drawing.
That's awesome.
Yeah. This makes life worth living, guys. Now you can create your own app called Etch-a-Sketch and put it out there.
Hey, this is the start of Snake as far as I'm concerned.
Hey, you got it. It's the start of a lot of things, really. Because who says that the key press is drawing a line? Now, if you think about it in that context, the key press, if you had a character, I don't know, like a Mario or something, right? That this could be his left, right moving, right? And then when you change directions, you might flip the image. You can do all sorts of stuff. All you really need now is your creativity. And see, that's where it gets kind of interesting. When you start to see it in that light, these commands become very powerful. When you think about that, all those first-person shooter games that you play or whatever, you know, where you're WASDing all around, you know, the virtual world, there's code like this that sits behind all those programs that's running all the time, that's always looking for those key presses. I think it's fascinating. Then you start to think about all the other key presses you can do and how they have probably like, you know, some sort of a method written that's handling all those key presses, you know. You know, so like if you're like switching weapons or tools or jumping or running or crouching or all those things that you do on a keyboard, all of that is mapped out. All right, so that was exercise 15.9, folks.
Really cool to think about.
Yeah, it kind of is. All right, we're going to start on the next one. Before we take our break, by the way, I just want to keep plowing forward. Any questions on this one? Everybody's okay? Making sure to check the chat window too. Okay, looks like we're good. That was exercise 15.9. What is our next one? Let's see, that is, you guys are really going to make me look, right? 15.18 is the next one, which is one of the even numbered ones. And 15.18 reads like this. Let's go down to that one. So move a rectangle using your mouse. Okay, well, this is kind of interesting. So in the first thing we did, we used the keyboard to control drawing on the screen, or really kind of like moving an object, and if you want to think of it that way. Now we're going to use our mouse to interact with something on the screen, and I think this is pretty interesting too. So it says, write a program that displays a rectangle. You can point the mouse inside the rectangle and drag, i.e. move with mouse pressed, the rectangle wherever the mouse goes. The mouse point becomes the center of the rectangle. I want you to think about all that, you know, like what they're pointing out here. So when you're moving, so if I was like to grab like this whole box and move it, wherever I let go, wherever my mouse is, that's where the center of the rectangle is going to end up. That's what they're saying. Okay, so this is kind of an interesting combination of problems here, because we're dealing with creating an object and putting it on the screen. Very simplistic at this point for us, right? Hey, we did Hangman, we got this down, right? But now we're going to interact with another user interface component, which is this little device here called the mouse, and to some of the actions related to it. And I think this becomes a whole lot of fun, frankly. All right, so let's begin with the basics once again. Let's create a new class file. So I'm down here in my chapter 15 part 2 exercises, and I'm going into Eclipse here and creating a new class file in this source folder. This is exercise 15.18. We get our public static void main in there.
That's a
And
question.
yes, please go right ahead.
When you like copy over like the like set title, set scene, primary stage, so on, should we just, since we're doing another interactive one, should we just bring over the request focus as well?
You know what? You know, I'm thinking that's not always needed for certain ones. So for example, what we're going to do in this particular situation doesn't require it, because the mouse itself, by virtue of clicking on the screen, sets the focus. This is what the difference is.
Okay.
That's a really good question though, Jay. And thank you for asking it. So like that's the question we often get. So why is it that I couldn't draw on that screen? It's because, first of all, I had to set it to be clickable. Then I had to software click on it, and then I could draw. Here, because I actually have the thing that clicks, you know, it handles it for me.
Okay, that's good to know.
Yeah, I mean, that's an excellent question though. Let's do the standard mechanics here as we always do. So we're extending the application class. Now, I'm waiting for it to underline, right? Did I spell it wrong or something?
Yes.
Oh, duh. Boy, it's not liking me, is it? Interesting. All right, so that makes me do a bunch of manual work here. I'm wondering what I'm doing wrong. I certainly didn't misspell anything, right? The jury's out, folks. Here, let me do a save on this.
I think you had spelled it wrong the first time, but I don't know why it's not working now.
Yeah. I thought
You just retype it.
yeah, you notice the other thing that's happening is I think my machine's kind of like weirdly locked up because I'm
Mhm.
saving right now.
And it's
Because-
not doing anything.
Yeah, it's not doing it. Fascinating.
I had Dreamweaver mess up on me the other day. Maybe things just break.
Dude, let's make it break. Yeah, it's like in some sort of a locked state or something. I'm going to kind of try to force it to behave, and then I'm going to reopen it because that's pretty weird. All right. Okay, so you guys saw what I did there. If you have a similar problem, hopefully you got a similar solution. All right, so let's get that library in there. Let's get the start method added. And let's move the main method to the bottom. You know, always these normal procedures here. And put in the launch directive. All right. Next thing that we're going to do here is we're going to think a little bit about our interface again. My thinking is if we're moving a rectangle around the screen, we kind of want the same kind of setup we had before, which is one large pane, whatever the window size is, and we'll work with that. Let's get the stage and the scene and all that stuff in there. And of course, it's not there. It is here. We can copy it from this one. Just copy that in. All right, this is exercise 1518 called Move Rectangle. Now, in terms of where we're going to start the rectangle, we have, you know, kind of like this issue once again of like how big are we making the screen? You know, I'm not going to do this whole dynamic thing. I am just going to hard code a screen of 500 by 500. I think a pane is the appropriate visual element to insert everything into, just a generic pane. So let's go ahead and add a pane class. We'll go once again with the name pane just simply because it's already down in the scene. And we're instantiating one new instance of it here. Yes, we will need the library. So control space to get that. And there you see it added. Now, right off the bat, we're going to go ahead and create the rectangle. That's really easy to do. So we'll just type that in here. And I did the wrong thing here. And we need the rectangle class. And I'm just going to call it rectangle lowercase just to make it easy. And we will make a new one of type rectangle. And then we will need some parameters. Once again, let's add the class first. Let's hover and add a Javafx Rectangle class. Then let's come back and hover again. And this time let's F2 and get to the Java doc and take a look at our possible parameters. With a rectangle, we can declare a width and a height of the rectangle. But I think we also need to, since we're going to be moving it around, we probably want a position. And I notice we have double width and height with a fill. We have the double X and Y, so those are positioning elements, and then a width and a height. This one seems pretty good to me. Let's go with that. So we're going to have to predetermine some of this stuff. And then based on our experience, we probably know that we have to put some color inside of it and put a line around it so we can just see it. But we'll go with 4 parameters, X and Y for position, width and height for size. All right, so let's go back to our code. And I'm just going to begin by going and doing something like this. If my window is 500 by 500, my starting XY could be like whatever that fits inside there. And I'm just going to pick some numbers. Heck, you know, let's start in the middle again. And let's just go 250. Oops, I must have turned off my numlock key here. Let's go 250, comma 250 for X and Y. And then let's give this thing a size and a shape. We don't want it too big. We don't want it too small. Let's make it 50 pixels across and 60 pixels tall. All right. Let's go ahead and style this thing now. Let's give it a fill and a stroke. So let's start with the fill. We're going to set the fill, and let's do a color. It's got to be a capital C on that. Color, I don't know, let's go blue. All caps on that. All right. Make sure you add that library if it doesn't come up automatically. And then let's go ahead and set the stroke on this too. And be any color you want, by the way, but I'm just going to do a basic black on this. And I think that will be okay. Now, if you wanted, of course, you could try to take a look at this, but you would need to add something that's going to receive that rectangle. And the way that you would do that is you're just going to add a pane, and then you are going to get children, and then we will add. We're just going to add a singular object here. It's just the rectangle, so there's no reason to have extra code or add all or anything like that. We're just adding the rectangle. Now, if you want, you could run this and take a look. But the next thing that we're going to do is we're going to get the mouse stuff working, and I think we're just going to plow through and finish this exercise so we can cross this one off our list. So the way that we would do this now is we're going to attach to the rectangle an event handler that, normally rectangles do not have event handlers, right? But we can add one of the user interface controls to it. So in this case, we're going to call the rectangle, and then we're going to set on mouse dragged, past tense. And I want you to notice as I do this, all the different options that pop up. And I think this is kind of interesting. So if you just do set on mouse, these are all the different mouse actions you can code for. Clicked, drag entered, drag exited, drag over, drag released, entered, exited, moved, pressed, released. And those are all of them. And so if you think about all those different aspects of it, so you can code to a click, you can code to a whatever, but the drag, is going to recognize that it's been clicked on, dragged, and released, all as part of that one event. So this is the one that we're choosing. And then we have to put now inside this value spot, once again, the lambda expression. And then a set of curly brackets to receive the code, then split them. All right. Now, in order for us to have this work correctly, the mouse drag has to basically check to see if it's moved to somewhere else. And this is kind of a hard one to really kind of express, but we need an if statement to do that. So what we're going to do is we're going to check that rectangle, and we're going to see if it contains, and this is a special command basically to determine where we're sitting in two-dimensional space. And so we determine that by actually taking the event handler and checking its X position, by the way, and then we're going to check its Y position. And why are we checking those? Because it is the spot of the XY that we're checking to see where we're going to place the rectangle when we let go. So what this is checking is to make sure that the XY is basically inside the screen. So if it's inside the screen, it will come up true, and it will draw the rectangle in the new spot. Kind of interesting, right, when you think of it that way. And so that's the part that's checking. Now we need the part that does the moving. And that part's actually pretty darn easy, because instead of getting the X, or retrieving where the current position is by virtue of the mouse, we are now going to set the position to where we want it to be. Now, where are we setting it to? We are going to set it to where the mouse is right now. So to set the X, we get the X. And that's always weird with mouse movements, but that's how it works. And then we are going to tell it to basically adjust its starting point. And I want you to think about this a little bit. Adjust the starting point of where it's going to be relative to the size of the object. So here's the thinking here. I want to place this so that the center of the rectangle is where I click my mouse, but I have to take into consideration the size and the shape of the object. So the X dimension is 50 across and the Y dimension is 60 up and down. And I want to be right in the middle of it. So when I let go, I want the X to be set 25 pixels different from where it otherwise started, if that makes any sense. So the way I'm going to do that is I'm actually going to subtract half from each one of those dimensions. So in the X dimension, I'm going to subtract 25. And then I'm going to do the exact same thing for Y. Right, so we're going to set our Y position by getting the Y position and then adjusting it, well, by half of the height, which is 60, so that'll be 30. See the thinking there? Right, and that piece you might not get right away, but that's how you get it centered on the mouse. All right, believe it or not, you guys, that's it. That's all the code. There's not a lot of code on this one. Once again, what really does a lot of the work are, you know, these event handlers, and then cleverly selecting the right methods to replace something on the screen. All right, let's save this. Let's run it, and then once we're successful, we will take a break. All right, so there's my square on the screen. Didn't really come in quite centered, right? You guys noticing that? Because, and let me explain why, because the top left corner is the XY. That is centered on the screen. So if you kind of look at it that way, so I could have added that same offset into my calculation. So what I could have done, if I wanted it to be absolutely in the center, I could have subtracted 250, 250 is the center, but that's the top left corner. So if I would have subtracted 25, I could have done, so I'm going to do this for the next run, okay? And then subtracted 30 here, then the center of the rectangle will be in the center of the window next time. You know what? I'm not satisfied with next time. I want to do it now, so let's fix it and just do it, right? Just to prove to you. There it is, right in the middle. Agreed? In the middle? Now let's try to move it. So I'm clicking with my mouse, and I'm moving, and it's ending up right where I'm moving it. Now this is seemingly ridiculously simple, but at the same time, the little bit of code that this takes, folks, is astounding to get this action to happen. You want to have fun with this one? Draw a whole bunch of shapes on the screen and move all of them. Right. If you're not happy with the square, make it a picture of, you know, your favorite character of whatever. You know, it can be any object, really. But, you know, then your math and stuff will be a little bit different because then you're working with that object relative to this space. But it's really easy little program. Excuse me.
Bless you.
Okay. Does anybody need help with this one, or is everybody okay?
I know if it seems like if I drag it around too fast, it'll stop, but I figured that was just that.
Yeah, mine kind of stops sometimes too, but it's mostly working.
Yeah.
Yeah, besides that, it's working fine.
Yeah, it depends on what your system's doing in the background. I think if I
have
looked at my
50 tabs open
CPU
on
clock.
Chrome.
All right, that's a pretty simple one, but you got to remember every time you're moving it, it's doing this math on the fly. It's reading positions.
This is really fun.
Changing them.
That's really cool.
Yeah, it really is. It's kind of a fun one. All right, folks, let's take a break. Come back in 5 minutes. All right, we're going to move on to exercise 1529. We are skipping over 15, 27, and 28. We decided that let's do the harder one since we don't have a lot of time left in class. The other two are recorded in other videos, by the way, so you can just look them up or, you know, follow the course link inside of our unit folder. All right, so 1529 reads like this. Racing car. Write a program that simulates car racing as shown in figure 1534A. So we're going to create this really special looking car, by the way. You know, so notice how they have, you know, an image of it sitting in one spot, and then it moves across the screen, and then they give you kind of like the dimensions of it, and they're giving you some hints here also in the margin on how to get the sizing right, by the way. Okay, so the car moves from left to right. When it hits the right end, it restarts from the left and continues the same process. So if you guys picture, it goes across, it comes out on the other end again. You know, another staple of video games, right? Like the little object that keeps rotating through the screens. All right, so it goes across the screen, comes back to the other side when it's done. You can use a timer to control animation. Redraw the car with new base coordinates, XY, as shown in figure 15.3.4b, and also let the user pause or resume the animation with a button press and release, and increase and decrease the car speed by pressing the up and down arrow keys. So we got like several different things going on here. So we're going to create an object, we're going to move it across the screen, and then we're going to allow the user to interface from the keyboard to control whether it's moving or not, so we can stop it, or we can make it go faster or slower with the keys that we press. So there's a bunch of different things going on all at once. The key new thing that we're really kind of adding to the mix here, at least tonight, is the animation piece. And whenever, you know, we think about doing animation, there's some key concepts that we have to talk about relative to animation. And one of them is the fact that animation happens over a period of time. So we're moving now from waiting for an event to happen to working with a timeline, right? So animations always occur over a period of time, and then combining it with user interface control. So it's really kind of a combination of two kind of sophisticated techniques. So let's take this one step at a time. Let's start building the main parts of the program first to get started. So we're going to come back here to Eclipse, and let's go ahead and create a new class file inside of here, inside of our source folder. This is exercise 15.29. We'll add the main method and go ahead and click finish. Let's do all our standard things. So I kind of feel like I don't have to talk through these parts anymore. But let's add our launch directive. Let's come up here and let's extend the application class. Let's see this time if it underlines. Hey, it's doing it again. That's pretty weird, right? All right, I'm going to use the same trick I used last time, which is I'm closing it and reopening it to get it to recognize that. I'm not sure why it's doing that. All right, add library, and then we're going to go ahead and add the start method. I'm going to move my main method to the bottom, and yes, I noticed the misspelling, just in case somebody was about to point it out to me. I did notice the misspelling all on my own without somebody telling me. I'm going to remove these unnecessary comments here as well and get rid of the unnecessary space in here. I am going to go ahead and bring in the stage and the scene components by just simply copying them from one of the other applications, just to get those up on screen here. And then I am using my cheat sheet now to try to figure out how I'm going to get this stuff on the screen. And so these are just the basics here. So the first thing I'm checking is what size screen should I work with? And you know what? When you look at the book, you know, it's definitely obvious that they're using something that's wider than it is tall. And so I'm just going to make kind of an educated guess here. I'm going to stick with 500 for the width, and I'm going to just change the height to maybe, I don't know, 100, maybe, something like that. Let's go ahead and change the title right away. So this is 15.29, and I think this is car racing, I think it was called, or something like that. All right. Now I'm going to start also thinking a little bit about the object that I'm going to display on the screen. So to me, it would seem that with working with the space that we have available, that once again, just a standard pane would be okay. Okay, so what I mean by that is a pane that just fills the whole space of the screen. Whatever the scene size is, it just fills the whole thing, because we're moving the car from one side to the other. It does look like they want the car at the bottom. They don't want the car flying through the air. They want it on the road. You know, so if you want, I guess you could draw a road even. but we're just going to assume that the bottom of the screen is the road. That's how we're going to operate. All right, so that's going to be my operating paradigm. And now that I'm looking at this, it probably doesn't even have to be as big as what we made it. And I might actually, I don't know, I'm going to make it a little less wide. Let's just go 400 pixels, I think might be better. Now, to get a pane on the screen is not a hard thing. So we've kind of done this already where we create basically a pane, do a default instance of it, and just start putting stuff inside there. However, what we are kind of missing here is this thought about moving an object. And I want you guys to think back to when we moved a ball across the screen. I don't know if you guys remember that exercise from the last batch of exercises. And in order to move that ball around the screen, we created a pane called ball pane, if you remember, like our own version of a pane that extended the regular pane class. So it brought all those capabilities. And then when we started doing things to move stuff around, that class itself interacted with the user interface controls, and more importantly, had all the movements built into it. And so we could just call them as methods from the pane class itself. All right, so what I'm going to do is I'm going to follow a similar technique here. And what I'm going to do is I'm going to create a class, a special class called car pane. And I want you to notice that as I create this, normally I would create this as a separate external file, but I'm actually going to create this internal to this class file. So I'm creating a class file inside of a class file, right? And you are allowed to do that, by the way. So I'm going to create this thing, instead of a ball pane, I'm going to create a car pane, and I'm going to extend the pane class. This will ask for a library, by the way. Let's go ahead and provide it.
I think you're outside the bottom curly bracket for the class.
Yes, I am. And the reason for that is because I'm starting a new class.
Oh, okay.
Okay, you guys with me on this?
I thought you said you were going to make a class within a class, so I got confused.
Oh, I see. Yeah, that's right. Well, in a sense, it is, because this whole file is going to be named after this class, but I'm including a secondary class within it, so I don't have to create a separate external file.
Oh, okay. Yeah, I misunderstood what you said. Sorry.
Okay. No, totally okay. Made me at least double check what I was thinking here. Now, I'm going to play with a couple of values here. And the first thing I'm going to play with is the fact that if I'm going to be creating a car pane class here, I'm going to be using it to move the car around the screen. So kind of the same way that I did with the ball pane and the ball, I'm going to come up here and I'm going to instantiate it. Even though I don't have a lot of stuff going on here yet, I'm still going to instantiate it. So I'm going to call upon my car pane, right? And notice it finds it within the document. I'm just going to call it car, and I'm just going to make a new instance of it. So I'm creating or instantiating a version. All right. And then I'm going to come here, and in the scene, I'm going to draw the car directly into the scene, remembering that the car will occupy the whole window, right? So the car in our mind is a thing within the window, but really everything inside there is really the car class and the pane and the whole bit. Right, now going back down to the car pane class, we're going to start to set some aspects of this. So the first thing I know is usually when I create a class file, I usually create a constructor, right, to go with any class I create. So I'm creating a constructor function that will exist here. And we will, in this constructor function, basically create the car on the fly. Okay, so there's some things that we will throw in here. But if you guys remember the anatomy of a class, one that we're using as a blueprint, by the way, we usually populate it with private variables at the top, and then we'll have a constructor function which, puts the thing together and spits out its properties and makes it a thing. And then we will add methods to it to allow it to move and slow down and speed up and all those things, right? But one step at a time. First, we have to create the private variables. Now, what makes sense to me is to create a size and a shape of the environment we're working in. I think that's pretty important. I think it's also pretty important to start actually drawing out little bits of the car. And if you're noticing here, the way that they did it is they actually combined 4 shapes, right? So they have a trapezoid, a rectangle, and 2 circles with predetermined sizes sitting relative to each other in 2-dimensional space. So that's what we kind of have to create. But I'm going to start first with the dimensions of the space that we're working in. So I'm going to create 2 private variables, both doubles, that will hold the width and the height of the space we're working in. And I remember that I set that to 400 wide, and the other one was set, the height was set to 100 pixels tall. And I'm predetermining that here so that I know that when I populate this into this space, it will fill it completely. I'm like predetermining the sizing. Interestingly, because I'm setting a size for it, if I pump it into this space without these variables here, or these parameters here is a better way to say it, it would become that size anyhow, by the way. This is just kind of like more of a fail-safe. Right, so that's just the size and the shape of the area that we're working with. The next thing that we have to do is we have to think about this drawing here, and I'm going to keep going back to this because this is very pertinent. When we're working in 2 dimensions, the 0, 0 point is in the top left corner. And we want to think about the car relative to certain positions on an XY grid. And, you know, we want to think in some ways that the car rolls across the bottom of the screen. So even though the objects that we're putting on the screen might have a starting X point and Y point that's not at the bottom, I still want to think about the car as an entire entity relative to the bottom, because that's how my brain thinks and not how the coordinate system works. And I do this mostly for my own benefit, by the way. So I'm going to actually create a variable called base X, which will be our X base point, relative to which all the other points will calculate from, right? And then I'm also going to create one for Y that will do the same thing. And the reason I'm doing that is that way, when I go to move the object, I can move those 2 aspects, and all the objects, all 4 objects I create will move together as one object. And so this is kind of one of the tricks of this, is realizing that you can create this all as separate objects and then operate them all together. But it takes a little bit of coding trickery, or common sense. I like to think of it that way, but I can assure you that you probably, sitting there in space all by yourself, would probably not think of these solutions all on your own. So that's why it's okay to do it in class together.
Is there also a way to use a binding property or something to just get everything like the same? One object.
That's an absolute possible thing, but the reason I'm avoiding that here right now is because I don't want to bind to the dimensions of the screen. My objective as a programmer should first be to get the thing to move, right? Then I can worry about the other properties. So I start with more fundamental aspects first. So I'm starting with a fixed space inside of a fixed window size. And once I figure out the mechanics of movement, then you can adjust to whatever you want. Then it's just a matter of setting variables to adjust, by the way. So I'm going to set these 2 variables that will help me to determine where I sit on the screen. And I want you to watch what I did here. So the base X position is at 0, meaning I'm presetting X to 0, which hypothetically I guess is at the top, right? Or no, it's not at the top. Where's X? It goes across. So it's where? All the way to the left side of the screen. So what I'm saying is my starting point for X is on the left, right? And then the car moves across and X will grow. The starting point for Y is going to be flipped. So here's the logic of it, right? So X starts at 0, that's fine. And as I move this way, X will grow. That's why it's X plus 20, X plus 40. They're showing you the dimensions. But with Y, I want to kind of think about the bottom of the car as my starting Y position. So Y will be equivalent to the height of the window. So if I make the window 100 pixels tall, the bottom part of the car will be at 100 pixels down in the Y dimension. And so it flips it. It measures how tall it is, and it sets Y to the height so that we're at the bottom of the screen. That's basically what's happening. So this is kind of like a reverse logic thing. So if I make the window taller, or if I change this dimension, that will change that H. Okay, so there's one of the ways you can make it a little bit more dynamic. Now I need to start building the pieces of the car, and we already identified we have a rectangle, 2 circles, and a trapezoid. And really there's no trapezoid library, by the way, so you have to use a Polygon tool to create that shape. We'll do the easy ones first. Easiest one is to create the rectangle, by the way. So let's go ahead and create that. All right. So we are going to create a rectangle, and I'm going to call that the body of the car. Looks like it wants a library. Let's go ahead and add it. And we are going to instantiate a new rectangle. All right. That is going to have parameters. And if you guys remember, the ones that we used in one of the previous exercises was XY position, right? So the top left corner, and then the width and the height of the car. Now, here's where we have an advantage. We have a diagram that we can work from. So where's the starting X? Well, at 0, right? So the left edge of the screen is going to be 0. So X is going to start at 0. Where is the starting Y? Well, if I'm looking at the rectangle, the starting Y is at Y minus 20. So let's get those first parameters in there. So the starting X is going to be 0. Now I could hard code the 0, but the car is going to be moving, so it's all got to be relative. So we're going with the base X position to start, which is 0. Then the base Y position, which we already determined it's at the bottom of the screen, but they said the top left corner is at Y minus 20. So I'm going to do base Y minus 20. Then I'm going to decide a width and a height. Well, it looks to me like from this horizontal line to that horizontal line is 10 pixels. And then it looks like 10, 20, 30, 40, 50 pixels across. So 50 wide, 10 tall. So those would be the parameters here. 50 wide, 10 tall. Those are hard-coded because the body of the car is not going to change. You know, those are always going to be that size, right? The position where it sits on the screen, the base X and the Y, that's going to move. But the shape, the last two are the shape, you know, basically, width and height. Those are not going to change. All right. I'm not going to worry about setting a fill or a color here. I just want to create the shape first. I'll worry about the other stuff later. Okay. Next thing we're going to do is we're going to create the next, I think, easy objects, which are the wheels, right? Because they're circles. Those are really easy to create, by the way. And so we'll call it, how about wheel 1? That looks like we want a library there. Let's go ahead and add that. And then we'll create a new circle. Then we need parameters for this. Now, the parameters for a circle most typically are the starting XY position and then the size of the radius. And so if I look at this, well, first of all, what's the diameter of one of those tires?
10 pixels.
Yeah, 10 pixels.
So the radius would be 5.
Yeah, the radius is half across, diameter is all the way across. It's pretty easy to see that it's 10 pixels all the way across. So it's very easy to determine that the radius is 5. The other thing that we'll think about here is the starting XY position. If this is 0 for X, that's 10. The center is
15.
15. And then the Y is going to be, well, whatever the base Y is minus
5.
5. Right, 5. Right. So that's how we're going to do the math on this. So we're going to go back here now, and we're going to say the x position is base x plus 15. We figured out 15, but we're adding to the base x because we're being dynamic here, folks. Then we're going to say base y minus what? 5. And then the radius of the circle is 5. All right, that's the one wheel. Now we're going to, we need wheel number 2, so let's go ahead and create that. The radius is already set, piece of cake. Do we have to change the y? Nope, because it's sitting in the same up and down position, but we do have to change this value to match the new x position, which we can determine from the chart. So it's 10, 20, 30, 5. So we're adding 35 instead of 15. Okay, so now we have rectangle defined, the 2 circles. Now we need the car top. And for that, we're going to use a library called Polygon to create it. So we're calling on the Polygon class. And why don't we call this car top, and then go ahead and make a new instance of Polygon. Give it parens. Let's go ahead and add that class in. And make sure you choose the Javafx one, by the way. All right. And now comes the fun part, because getting this code put together is a little bit different than making a rectangle or a circle. It's slightly more complicated. And you know what? I'm not going to pretend that I memorize what the parameters of this are. That's totally not the case. But what I'm going to do is hover. Let's go do an F2 here, bring up the Java doc, and let's do a little research. All right. So the format for providing the constructor function can be empty, double points. I don't think so. You can feed an observable list into it, I guess, or take it to a string. But really what happens here is what we're putting in, and what they mean by double points, is that all the values that go in here have to be doubles. So they can be pixels or half pixels or part pixels, by the way, and that's because of scaling. But we're going to put in the coordinates of the polygon vertices. And what that means is when you draw a shape on the screen, and I'm going to attempt to do this just with the built-in zoom tools. So wherever I start my line has an XY, wherever it ends is an XY. And then when I go from here to the next segment is an XY, starting an endpoint, starting an endpoint for another XY, and then starting an endpoint for another XY. And so the trick is you got 1, 2, 3, 4, 5, 6, 7, 8 XY positions that we have to determine, all from that little chart in the book. Now, thankfully, we have that chart. And so knowing that each one of these line segments has a starting X and Y, all of them are relative to base X and Y. That's how we're going to do all the calculations. So we're just going to be really methodical and start with the first point. And for me, the first point is this one. So what's our X there? 10. What's our Y there? Minus 20. Okay, so there's our first calculation, or XY coordinates. Let's see if I can get back to Eclipse here. If I can fumble with my Alt-Tab enough. All right, so here we go with the polygon. So the first one is going to be base X plus 10. So we found a position of 10. And then the Y position for the starting spot is base Y minus, what did we say the number was? 20. That line segment goes from X10, Y minus 20 to X20, Y minus 30. Got that? Which looks like this. And yes, I am cutting and pasting at this point, folks, because I am looking at the clock, by the way. We're going to need another set of coordinates here. And if we follow around that shape, you will discover that the next line starts here, and then the final line is from here to here. So that's the complete statement for making that shape. All right. So now we have all the pieces that we need to build the car. All right. Next thing is in the constructor function, we're going to do the filling and the stroking and all that other stuff, and the appearing, more importantly, getting it on the screen. That's what happens in the construction. So there's nothing that's going to send in. By just instantiating, the car will appear. First thing that we're going to do is we're going to take that body and we're going to set the fill color and I think they want us to make it green. All right, so I'm going with green. All right. Next thing I'm going to do is I'm going to color the car top. And for that one, I'm going to set the fill to a color. Let's see, last time I did it red. And heck, let's go with that again. All right. What about the circles? What colors will the circles be? They're going to automatically be black, by the way. They're going to be filled black automatically without me filling them, just so you know. So that part, we don't have to like do anything with that. Now, lastly, we have to put this stuff into the pane. Now, because this is the constructor function, I'm going to use the this directive. And if you guys remember this, what this is it's a self-referring indication. So in other words, this is referring to itself as it's being created. And itself will want to get its children and then add all the required pieces. And there's more than one piece, so we're going to do an add all. And I was hoping that it would, there we go. And now we're going to get all the pieces and place them in here. So the first thing we're going to get is a wheel. So wheel 1, wheel 2, the car top, and then the body. Now, some of you might go, well, it doesn't matter which thing we draw first. No. you know, hypothetically, they're drawn on the screen one at a time, but they happen so fast you can never like humanly perceive it. It just will appear to just all come on there at once. All right. So this already is enough for us to at least get the car on the screen. Then all we're left with is the controls and the movement. And I know we're running out of time super fast here, so I'm trying to get this car on the screen. I already have it instantiated up here. And let's just see if we can make it appear. So at this point, save your work and let's just hit the play button. And if we can get a car on the screen, hey, well, that is not great. It looks like I'm missing a line segment for the car top, right? Yeah, I totally am.
Yeah.
Right. Yeah, not good. We got a little repairs to do here. Am I missing? I'm missing a set of coordinates. I have to be. And I wonder what happened to them. Did I accidentally delete them? I must have. All right, that's great.
It's a sports car.
Yeah. You know what? Yeah, that's it. It's a sports car. But I could figure out what the problem is here, because what the line that I'm missing, if you think about it, we could, this one's taking us to the wrong place. So I'm not sure what I copy pasted wrong here, or if I just, like, as I was fixing my code on one screen, broke the code on the other screen. So I'm going to see if I can pull back the original source code here. All right. Did anybody figure out these coordinates and want to help me out?
No.
Nobody wants to help. Oh, I get it. Oh, I see how.
I'm working on it.
Well, I know that this one actually should be the same Y. And I think I'm just missing one extra set of coordinates here. And so if I'm going base 20 to base Y 20, let's see where that puts us on that screen. So this is the kind of stuff you're going to run into. So the Y stays at 20, but the X increases to 30. Oh, Tom, you're awesome. Thank you. Anything I can do to save a little bit of typing. All right, so if you guys look at Tom's little solution here. Here, Tom, I'm just going to copy all your code. It better be right. Yeah, well, you know what, Tom? We're going to find out in just a sec. So I'm just replacing all of mine with Tom's. And so now we'll see if Tom is correct. And of course, I don't know if it pasted in also cleanly, but I'm going to just clean it up a little.
Great work, Tom.
It works.
Yay.
Thank you.
Tom will send you a bill in the mail. All right, let's go ahead.
Disappointed I'm broke.
Well, it doesn't work that well. There we go. Yay. All right. So we were just missing one set of coordinates, but that was enough to make our car look silly. But there it is in the bottom left corner of the window, ready to roll. And now let's see if we can get it to the rolling point because our time is flying here. All right. So here's the next aspect of this. We do need this to animate. So the first thing we're going to do is we're going to add a couple of the animation pieces. So we're going to start here. Normally the stage and the scene would go at the very bottom of the start method, but in this case we actually need the stuff to show first before we can move it. And so once we have the car pane instantiated and put on the scene, now we can set focus. So I'm going to take that car pane and set focus. Next, I'm going to trigger a timeline to get the animation started, and I want you to check the syntax on this. First of all, we will need the library. So let's get that up on screen. And we're calling our timeline animation. I do want you to notice that it is, as part of the timeline, it's instantiating what we call a keyframe. And normally I do this whole spiel on what keyframes are. But basically in a timeline, a keyframe is a triggering event. It's kind of like a thing that says, okay, happen now. Is kind of the way that I think of it. It's a starting point for an event. You will notice that this is highlighting, and it does want basically a library for keyframe. And I want you to notice that you got to pick the right one here. So Javafx animation keyframe, and that will take care of part of it. And then the duration also needs a library as well. Just make sure it's the Javafx utility. All right. Now the keyframe will be the starting point for the animation, and then it also tells us how long the animation lasts, and that's what the duration piece is, in milliseconds. So 50 is equivalent to 50 milliseconds, or 51,000ths of a second. So this thing is going to move pretty fast. Now I want you also to notice that right inside the keyframe itself acts as an event handler. So it acts as a trigger without the user interfacing. The timeline just happens, and then something is actuated. And in this case, we're looking to move the car. So we actually need a method down below to do the movement. All right, so let's go now and create this thing. And I want to show you something that's really kind of interesting here. It recognizes there's a car class and a car pane. And I want you to notice that I can automatically, it recognizes this method does not exist. And look what it's about to do. It's going to create the method for me, folks. And this is a, killer feature of Eclipse, by the way. So now when I come down here, you're going to see that it automatically set up a method to move my object. Now, it doesn't know what type of return to do, but I'm going to tell you, we're not returning anything. We're just moving stuff. So we're going to set this to void. The name move is perfectly fine. And we are not returning a darn thing, so we're going to remove the return statement. Okay. Moving is actually pretty darn simple because we're only moving one direction. And what we're going to do is as we move, we are going to go across the screen, right? So what are we changing as we're moving?
Base X.
Base X. Excellent. And every time this thing runs, and what this basically is saying is there's a keyframe every 50 milliseconds that will keep happening. And every 50 milliseconds, we will ask the object to move a specified amount. And you know what? Maybe even 1 pixel is adequate. So that's what we're going to start with. However, if we discover that the car becomes too far off to the side, so if it gets maybe to the right edge of the screen with 400, so hint, hint, and if it exceeds that value, then we should push it back to the beginning and have it start over. And that's what I'm going to code first here. So that first part is we're going to check to see where it sits right now. So if it sits at a point where the bottom corner of the car has exceeded the width of the window, I'm going to reset that to -50. Now, why -50? Because that will start the car off the screen, ready to come back in, right? If I would set this to 0, the car would just appear, boom, right on the screen. It wouldn't come into the screen, it would just appear. And that would look a little awkward. The else to this statement, if it's not off the edge of the screen, then we are just going to go ahead and move it 1 pixel for every click of this animation. All right. And then on top of it, once we have that done, then we're going to take whatever these revised calculations are, and we're going to rewrite them back to the object. So this is the part that's kind of weird. Every time we move it, so every time it moves a pixel, I have to record where it moved to. And so I think it might be easier, rather than doing it here, to actually create a separate method that does that for me and keeps this code clean. So once again, I'm going to create another new method, and it will be internal to this class called setValues. I will not be returning anything. And all I'm going to be doing is taking all the object positions and changing them. So I got to move the wheels, I got to move the body, and I got to move the car top. And so here is how that's going to go. And rather than worry about typing this all out and explaining it, here is all the code, because we are that much out of time. And so what we're doing is, for each wheel, we're resetting the X and the Y for each one, right? And then for the body, we're doing the same thing. And then for the car top, we're doing the same thing. And this is a little bit different for the car top because we're dealing with Polygon. So they have a separate method. So instead of setting the X and the Y, we're getting the points where it currently is, clearing it, and then resetting it. That's how that one works, if you have questions on that one. All right, so those are the two methods. So by calling move, it will detect if we're off the edge of the screen and start us over, and then reset all the values for X and Y, which it does in a separate method down here. This is listing as private. That's fine, but in some cases, some people would argue that should probably be public. But those are the movements, folks, and hopefully you got a chance to screen copy that or whatever. The next piece is to actually get the animation running. And so for that, we need these 2 lines of code. So this is going to go right below the timeline. And so here you're going to see the animation. We're going to set the cycle count. It is, how many times do you want to do this? Well, we're going to keep this running. As long as this program is running, that car is moving. So the command for that is indefinite. Otherwise, you can put in a time frame. The other thing we're going to do is we're going to initiate the play command so the animation starts automatically. Right. Let's see if we can get this piece working, and then we'll add the other 2 controls. And I realize we're over time, but we're going to continue and finish this if you guys don't mind. All right, so here it is. Let's run this and take a look. Let's see if that car really moves. Hey, it's moving. Oh boy. But for as simple as that is, it's kind of impressive at the same time that you're able to move something, and really you're moving 4 objects at the same time. All right. Now we're going to add the other pieces. The first thing we're going to do is really easy. So one of the directives was give the user the ability by pressing certain keys to make the animation stop or start. And in this case, if you press the mouse button down, it will stop. If you release it, it will continue. Let's try this. Saving it and running it. So here I am with my mouse. I'm clicking to stop, releasing to start, stop, start, stop, start. Pretty slick, right? Very simple, but very powerful. The next command, I'm just going to paste the whole thing on the screen, by the way. Let me get this off the screen. And this next piece is the piece that allows us to put in the event handler that will respond to the keyboard now instead of the mouse. We do need to add the key code libraries for JavaFX. And then you can see I have an if statement that checks to see if it's pressed up. We're going to change the animation rate by 1. And then if we press the down key, it will change it by -1. So it'll basically change the speed of the animation based on what we have going down below. All right, so here goes the final version of this, folks. Let's go ahead and run it. So there it is. Stop, start, up key, down key.
Nice. What are the coordinates on your on the wheels? My wheels are acting a little weird.
All right, here's my my coordinates right here.
Okay. Okay.
You know, and at this point, what might be smart, Javier, is just a screenshot there. That as I have the code on the screen. All right.
Okay.
I am going to stop this recording here. This is the completed exercise, by the way. So here's the top part of the code. It's my standard practice through line 28. Second part of the code through line 57. And then next part of the code through line 84. And then finally the bottom of the code. All right, this recording ends here, folks.